Greetings everybody, we're just about to do part B, but let's take 30 seconds and just review what does the solution to part A look like. So I've got some private instance variables, x and y. I've got my constructor, which initializes them. I've got distance2, which uses math.square root of the difference in the x squareds and the difference in the y squareds. And I think it's good practice to use a getter method. And if you haven't written a getter method, then you can always feel free to write one. Is right of, I have a very concise answer that just involves testing the x coordinates and then returning the result of the test. For r close, instead of recalculating the distance, I just used the distance2 method that I'd written up here, and then I used the same trick of just returning the result of this answer. And then I have several getter and setter methods that I decided to write just because it's convenient to be able to do so. If you have questions about this, you can of course go ahead and look at the previous video. Okay, part B says create a tester or client class in which you create an array list of point objects like this. Write a loop which loops 100 times, create a new point with random xy coordinates in the range, that is a typo. I'm going to create it in the range from 0 to 100 and add it to your list. Great. So here we go. I'm going to create my array list of point. And I think it's a good idea to have the word list in there or in some way indicate that it is multiple items. So you could call it like points, or I like even better point list. So new array list point. Okay, and then array list is something you have to import. And now I'm going to loop 100 times. Whenever you know that you're looping a fixed number of times, you should always use a for loop because that's what they're there for. And this is the conventional way of looping 100 times. You don't have to call your loop counter I, but it's conventional too, and just 0 to 100 with a less than. All right, so I'm going to create a new point now with random xy. So I'll say point p equals new point, and now I want the two inputs to be random numbers between 0 and 100. So I'll say math.random times 100. This is not including the number 100. Which is okay with me. And now let's do math.random times 100. So this is like from 0 to 99.99999. And now I'll say, what did I call it? Point list, point list dot add p. Great. All right. It is, of course, possible. I don't need this variable here. I could embed this inside there, and that would work just fine. This is not my favorite solution necessarily because you're doing a lot of things on one line, and if this was a more complicated program that needed debugging, you would want to test lots of these things separately, and this would make it hard to do that. So I think I'm actually going to leave it as the 2 lines. What are we doing now? Some people were asking whether or not you can tell that it actually worked. So there's a bunch of things you can do. An easy thing would be you could do system.out.println, and let's do this, point list.size. So I just want to display at the outside the loop how many things are in this list. So if I run it, it should display 100. And that's at least a way of checking to see, does my list have 100 things in it? Well, all right, let's check to make sure that the things are what I expect. So one thing you could do is, let's get out the last thing in the list. Let's say point last equals point list dot get. I want to get the last element, which is the same thing as point list dot size -1. So I'm getting the last location. And now that I have the last element, I could try and print last. Because I want to display what's that point. You'll see what happens. Some of you might know. So here it displays this weird thing where it says org.fhsd.point. So this is actually a reference to the memory location where this object is defined. So that's not helpful. I actually want to see what are the values in the object. So let me show you a thing you can do. You can go back over here to the point object, and let's make a new method. This is a special built-in method. This is a special built-in method called toString. The way you should think about that name is it's like you're converting your current instance to a string. So I'm going to return a string that represents my object. So I want to return the x value and then the y value. So this is going to return just the information that I want to see about my object. And now that I've made this toString method, of course you could run the toString method inside here. I could say .toString, and it would display, because it's returning a string, which is then getting printed by my print statement. So there we see it. But what's nice about toString, I said it's a built-in method, so that method gets run automatically if an object is inside a print statement. So this is going to do the exact same thing when I run it. And the numbers changed, of course, because they're being randomly generated. So that was another just simple test. I just got the last element out of the list and printed it to see if it makes sense. Let's do a last approach. Let's use the debugger to inspect the list, because that's a nice interactive way of seeing the entire list at once. So you can put a breakpoint in IntelliJ, you can anyway by clicking just down here in this column. Actually, I'm going to put a breakpoint. I'm going to put a breakpoint here. No, here. Okay. And then when you run it, instead of saying run, let's say debug. And what a breakpoint does is it will pause the execution as the program is running. So the program's running, only right now it's paused right on this line. You can see some other things. This is the line of code, but you can see that it's inserted point list colon size equals 0, p, and then some information. So here it's already displaying that the variable p has this value, it's an object, and that right now the point list size is 0 because I haven't run this line of code. If you click here, is this the right one? Step over. Yeah, so if I click this line, it will run that line of code. And now you see down here, it says point list has size of 1. And if I click there, it shows me element 0 is a point with those x and y coordinates. So let's click step over a couple times. I create another point, I add it to the list. I create another point, I add it to the list. I create another point, I add it to the list. And you can see down here, now my point list is size 3, and this is element 0, 1, and 2. And you can see what the xy coordinates are. So here, you can watch it happening, and you can see that it's doing the right thing. I'm adding a bunch of points, and you see that the xy values are in the right range. And then when you want to stop it, you can click this red box. So that's another approach. Eclipse can do this, but I would recommend that you download and install IntelliJ, since that's the one that we're going to be using. All right, let's do bonus problem C. It says write code to find the point which is furthest right of all the points in the list. So I'm going to clean things up a little bit first. So I'm going to cut this code, and I'm going to make a method that does this. So make random point list, and it's going to be size 100. And I'm going to create that method. Oops. And I'm going to create that method here, and then I'm going to go ahead and paste my old code. And this is going to be called size. And this is going to be size. And I still need to make my new list. So array list point. Point list equals new array list point. Okay, so I'm making my empty array list. I'm looping now size times. I'm making my things. I'm adding them to the list, and then at the end I'm going to return it. Return point list. All right. So the reason I did that is because now I can this button shows and hides the code. So now sort of that's out of sight and out of mind, and my main method is uncluttered. I know that the first thing I'm doing is I'm making a random point list. All right, so next I'm going to define a variable called most right, and I'm going to make a method for what I want to do. So get point furthest right, and I'm going to give it my point list as an input. So the further you go in programming, you want to think about things in terms of inputs and outputs. I'm not just writing 87 lines of code just in one big file. I'm really defining a logical command. I have an input that's a list, and I'm trying to figure out what's the furthest right point in the list, and I'm going to return that as my output. So here I'm returning a point object. The input is an array list of points, and now I'm ready to actually start my coding. So the point that's furthest to the right is the one with the largest x coordinate. So here's the strategy. I'm going to create an x coordinate called most right, or like furthest right. But let's say, yeah, furthest right so far. So the furthest right so far is 0. I'm going to initialize it to 0. And now I'm going to loop over my point list. I'm going to use something called the for each loop here. So I want to loop over every element of the point list. And what's the data type here? Each element is a point object. So I'm going to declare a new point object, point P, and then I have a colon. So what this does is this is a shorthand way of looping over every single item in this list, and each one gets assigned to this variable. So the first time through the loop, variable P is equal to point list element 0. The next time through the list, variable P is assigned point list element 1, and so on. All right, so let's do this. So the x is going to be p.getX. And now I want to say if the x variable is larger than furthest right so far, it must be the case that this particular point is further than the furthest right we've found so far. So I want to save it. I guess let's create a point object, which I'll call answer point, and it'll start out at null. So if the x value is largest than our furthest right so far, then my answer point is going to get saved as, or I'm going to save P as my answer point. So all I'm doing here is I'm looping over every single thing in the list. I'm saying, do you have the biggest x coordinate I've seen so far? And if the answer is yes, then I'm going to save that point as a possible answer. But then, of course, I go to the next item in the list and I say, let's look at your x-coordinate. And is your x-coordinate bigger than the furthest I've seen so far? So in order for this to work, of course, I would have to say furthest right so far equals x. What happened here? Because I need to save the x-coordinate so that way it updates to reflect what my current answer is. So once I'm at the end of the list, I've checked every single point. So the most recent one I saved must be the one with the biggest x coordinate, and I can return answer point. This is maybe not the cleanest way to do this. There are some improvements. I guess let's talk about the improvements. So in some respects, this might be extra. Like, furthest right so far is really just the x-coordinate of the point object that I found. So let's delete this, and instead of furthest right so far, let's just say answer point.getX. So I'm comparing the current x value to the x value of my possible answer point. And then I don't need to save this at all. So that's a little bit shorter. The problem is, what should my answer point start out as? Let's do this. Let's start the answer point as the first element in the list. Because if the first element in the list happens to be the one that's furthest right, then great. This is never going to be true because all of the points have a smaller x-coordinate, and at the end I'll return element 0, which is what I initialized it to. If it turns out that the first point in the list is not the furthest right, then at some point later on, this is going to be true, and we're going to replace the answer point with one of these other points in the list. All right, so now maybe it's not worthwhile to have this double x, because I'm trying to compare, is point P's x-coordinate larger than the answer point? So let's do p.getX. So now I'm saying if P's x, and P is just my current point, so if P's x is larger than my answer so far is x, then let's save it as my answer so far, and let's return that at the end. So this is maybe a little bit shorter, a little bit nicer. So now back here up in main, I can print most right. And let's go ahead and run it. So the furthest right here, it's at 98, that seems plausible. Let's run it again. Here's at 99, that seems plausible. So this, I haven't actually checked to make sure this works. If I really wanted to test this carefully, we would need to control the input list so that we know what's in it, rather than making a random one. But again, I just wanted to do a sense check, and this seems sensible. I'm not seeing values that are very small compared to what my maximum range is. All right, let's do the last